Okay, we have this circuit. It's a single mesh, single loop, and we want to solve it. We want to find out for this problem the power absorbed in each element. So compute the power absorbed. Well, it could be supplied, but maybe I'll do absorbed or supplied. We'll do all of them by each element. And to calculate the power, either absorb or supply, you need to know what? The current. And I have no idea which way the current is going to travel, so I'm going to take a guess because my source is minus to plus. Normally through a source, the current will go from minus to plus. But then we got that one here. So I'm not really sure. I think it's going to go this way, so I'll make an assumption that my current is going to flow in that direction. And if my value for that current is positive, my direction is correct. If the value is negative, the value is correct, but the direction is wrong. So I'm making the assumption it's going to go in that direction. Let me do KVL, Kirchhoff voltage law, and see what will happen. Let me start with this. That's entering the minus. Minus to plus, we've been using what? Positive. As I said last time, it really doesn't matter as long as you're consistent with it. In one problem, you can change it every other problem. But as long as you're consistent in that problem. Now, if the current going this way, I'm making sure this is plus to minus. So the current through resistor, I'll mark it plus to minus, so this will be a minus. Ohm's law says the voltage here is what? V equals I times R. And that would be I is what? I and R is 30. What's I times 30? 30I. This is plus to minus. That's a minus 2VA. Minus to plus, that's what? Plus VA equals 0.
How did you determine that that resistor is plus to minus?
The current through the resistor will always mark it plus to minus. Unless they label like this intentionally. So this actually, when the current goes through that, is going to mark the resistor plus to minus. Because the current's traveling in that direction. So now if you look at this equation, if you clean it, 120 equals. Now this will be what? 30I, if you move it to the other side. What's negative 2VA plus VA? Negative VA, move it to that side, that's what? Plus VA. So now we have one equation by how many unknowns? 2. We can't solve it. We need another one. Well, I is going through that resistor. As I said, it's going to mark it plus to minus. So if I don't pay attention to this, the voltage here really, if I don't pay attention to this, it's Ohm's law. V equals I times R. I is I and R is what? 15. This voltage here is actually plus to minus what? 15 times I. But notice how they label VA minus the plus. That means VA is going to be what? The opposite to that. The polarity is backward. They have the minus on the top, the plus on the bottom. This is the plus on the top, the minus on the bottom. So VA is negative 15I. So now there's my second equation. I have two equations now by two unknowns. I can use substitution, plug it in. 120 equals 30I plus, in place of VA, I'm going to put what? Negative 15I. 15I equals what? 120. What is I equal to? Oh, forgot a calculator. I forgot an eraser.
That's 8.
What is it, 8? 8, yeah. So I is 8 amps. So once we have I, we can calculate the power through either absorb or supply by each one. So let's look at it again. Let me redraw the circuit. That means my direction is correct. So I'm going to redraw the circuit, put the values in it now. I have 120 volts, and I got 8I going up. 8 amps, I mean, going up. This is 30 ohms. We got 8 amps going this way. This is marked plus to minus. The current will mark the resistor plus to minus. Plus to minus. I got 8 amps going this way. We'll get this voltage in a second here. We got 8 amps going this way. And this voltage plus to minus is what? 15 times I, right? What's 15 times I? 120? Remember, this is negative to plus VA. That means VA equals what? Negative 120 volts. So what's the voltage here? 2 times VA. What's 2 times negative 120? Negative 240 volts. And if you don't like negative there, sometimes it's not a bad idea to keep drawing them cleaner and cleaner. I don't like that negative. So I'm going to reverse the direction of that and make that value what? Positive 240 volts. And now I can calculate the power absorbed or supplied by each one of them. This one, the power, I'll do the supplied versus the absorbed here. I got a current entering the negative end. Is that supplied or absorbed?
Absorbed?
Try again. Supplied. The power for the 120 volt source, that's this source here, will be negative, that means supplied, 8 times 120. Remember, power equals what? V times I, or I squared times R, or V squared over R. For this, I know the voltage, I know the current, so I'll use the top equation. Eight times 12, or 120, it's what, 960? Again, the negative means supplied. I have 8 amps going through that 30 ohm resistor, entering the plus. Is that absorbed or supplied?
Absorbed.
So that's right here. The power by the 30 ohms equals positive, which means taken. I know the current, I know the resistor. Maybe I'll use the second equation. I squared R, which is what? 8 squared times 30. $19.20. Watts. Now let's go to the dependent source. A positive current entering what? The negative terminal, supplied or absorbed? supplied. So this is the dependent source. It's going to be negative. I know the current, the voltage, I just multiply them. 8 times 240, which is negative, I think 1920. 1920. Let's keep going to that resistor. I forget how big that resistor, how big was it? That was 15 ohms. We have a positive current entering this positive that's absorbed. That's the power by the 15 ohm. It's going to be positive. I know the voltage and I know the current. I can use that. V times I. That's positive 8 times 120, which is what? Positive 960. And when you add them, if you add the sum for both of these, 0, 6 and 2, what? 8, 9, 9, 18, 8 carry 1. And what about the supplied? Negative 2880 equals to that number. The power supplied, the power absorbed, they have to equal to each other. Let's take, that was a single loop. Let's take a single node circuit here. So I did the single loop, which means one mesh there. The current is the same when you only have one loop. When you have a one node, that doesn't mean the current is the same. It might not be. Most of the time it's not. But what about the voltage? Let me draw a picture. Maybe if you see it, you'll see the answer there. The single node circuit. So let's take an example. $120 amps. This is labeled as R1, which equals 1 over 30 ohms. Independent current source pointing down of the value of 30 amps. And I have another resistor here, R2, which equals 1 over 15. The question is, find the voltage, comma, current, comma, and power associated with each element. I can answer the first question. I can answer the voltage. Well, not yet, but I know one thing about the voltage. I shouldn't say I can answer. I know one thing about the voltage. What's the voltage here and the voltage here and the voltage here and the voltage here? The same. So we have the same voltage going through them. But we don't know what that voltage. So if I make this the ground, there's only two nodes in the circuit. If I make this my ground, this is my ground, D, and the top is a node, but I don't know what the voltage to the top. I'm looking for it. That's what the question, what's the voltage? That voltage should be the voltage here, 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 and here. So let's call that voltage V. It's unknown to us. How many nodes do you see there? 1, right? So let me do KCL, Kirchhoff current law. Kirchhoff current law says the algebraic sum of the current is 0, or if we take all the current, we add them, the ones going into the node should equal all the current coming out of that node. All the current going into that node should equal all the current coming out of that node. Does that actually look clear up there? Is it clear? Yeah. Because I'm using these pens, like I said to listen to Rich use a small pen because I can write more. And I have going to the node, I'm leaving a space, I have the 120 amps, and leaving that node I get 30, but that's not the only thing. What about the current through these? Does anyone know which way the current through these going? Not really. So we can take a guess. Doesn't matter if you're right or wrong, just the direction. So let's say I'm going to assume the current is leaving this and leaving that one. I'm just making that assumption. And I'm going to label this I1, and I'm going to label this I sub 2. So what's the current going to that node? 120, because I labeled them all leaving then. What's leaving the node? The 30 plus what? I1 plus I sub 2. Do the math. What's 120 minus 30? 90 equals I sub 1 plus I sub 2. One equation, how many unknowns in it? 2. We got a problem. You can't solve one equation with 2 unknowns. Not even Mr. Burns can solve this and get a number for it. You can solve for I sub 1 in terms of I sub 2 or I sub 2 in terms of I sub 1. But you can't get a number for I sub 1 or I sub 2 just from that equation. So I need to make sure we rewrite these using one variable. Well, let me go back to Ohm's law. Ohm's law says V equals what? I times R. Which means I equals what? V over R. Well, let me look at I sub 1. Can I write I sub 1? I sub 1 is the voltage here, which is this voltage minus that voltage. If you're going from here to here, it's this minus that. So it's V minus 0, because the ground is 0, divided by that resistor. What's that resistor? 130, right? So when you do the math, I sub 1 is equal to what? 30V. And I sub 2, let's look at I sub 2. I sub 2, that's this current right here. It's coming this way. So it's this voltage minus this voltage. V minus 0 over what? 115. What's I sub 2? 15V. Now if I bring both of these numbers back with me and I plug them in here, I'm going to have what? I'll go on the next page. So I'm going to have 90 equals, in place of I sub 1, I'm going to write 30V. In place of I sub 2, I'm going to write 15V. 90 equals what? 45 times V. That's not 45 voltage, that's the variable V. I should call it maybe Vx, would have been a better choice. What's V equal to? 2 volts. So here's the first question. It says find the voltage. Here is your answer. 2 volts, right here, right here, right here, right here. So if you want to answer them, the voltage across the 120 amp source is 2 volts. The voltage across R sub 1 is 2 volts. The voltage across the 30 amp source, it's 2 volts. The voltage across R sub 2, it's 2 volts. They're all connected in parallel, must have the same voltage. So it is plus to minus this way, 2 volts, the voltage across each one of them. Now, can we find the current through each one? Well, we know this current, we know that current. I need I sub 1 and I sub 2. Well, wait a minute. I know what I sub 1 and I sub 2. I sub 1 equals 30 times V. V is 2 volts, that's 30 times 2, which is what? 60 amps. I sub 2 is equal to what? 15 times V. 15 times 2, which is what? 30 amps. So we know all the currents now. We know all the voltages, we know all the currents. Now, can we get the power? Sure we can. I'll draw the circuit nice and neat so I can do the power, so I don't have to move up and down the whole time. This is what I have. I have the source. That's a current source. I'll make life easy instead of erasing it. Flip the page. I got a source of what's the value? 120 amp. And the voltage is plus to minus what? 2 volts. Going across resistor 1, which has a voltage plus to minus 2 volts. And we just calculate the current through that. The current through that's I sub 1. And what was my I sub 1? 60. 60, not 6. Oh. Uh-oh. No, I don't like scribbles. 60. Let's get another one. That too. Now, what else do we have? We have a current source here of 30 amps. We know the voltage here is what? 2 volts. We have resistor 2, has a voltage here of 2 volts, and we know the current through it. We calculated that 2 from before, 30 amps, right? So now we can calculate what the power we have this current going up. It's entering what end? The minus? So is that absorb or supply? Supplied. So the power by the 120 amp source is going to be negative, which means supplied. V times I. So that's negative 120 times 2, which is negative 240 watts. We have 60 amps entering the plus. That power is being absorbed. V times I. 60 times 2, positive 120 watts. We have a current, you notice that 30 amp entering what? Positive. That's also absorbed. V times I, and the voltage is 2, and the current is what, 30? That's plus 60 watts. And the last one, we have 30 amp entering the plus. That's also being observed. Here we go. Positive voltage, which is 2, the current, which is what, 30. That's positive what? 60 watts. When we add them, 60, 60, 120 is what? Positive 240. And what was the supplied? Negative 240. Are they equal? Better be. Conservation of energy. Power. Let me put a dependent source in it and see how that works. This is 6 kilo ohms. This is a current source with the value of 2 I sub x. I'll look and see where I sub x is. This is 24 milliamp current source. Milli 10 to the minus 3. And this is 2 kilo ohms. This current is labeled as I sub x. This is I sub 6, is the 6K. This voltage here from top to bottom is labeled as V. And the question, find V and the power supplied by the independent source. Independent source, that's this guy.
It says IB.
I sub 6, the 6K.
Oh.
Find V and the power supplied by the independent source. So that's the only one they care about, the independent source. Is anyone out today? I think we have everyone, huh? Ken, yep. Again, if I make the bottom ground here, that's ground. That voltage on the top is known as V, because that's this voltage right there. So this is one node right there. The voltage there is V. Now I can do KCL. The algebraic sum of all the current entering a node is 0, or again, all the current going into the node should equal all the current leaving that node. I in equals I out. We define I sub 6 coming down. We got this one going in, we got this one going in, we got this one going in. So let's go ahead and plug them in. What is going to that node?
2 I sub x.
2 I sub x.
I sub x.
plus that 24 milli, right, which is 0.024, 24 milli, milli is 10 to the minus 3, plus I sub x. And what's leaving that node? I of 6. So we have two unknowns. Because if you clean this, 0.024 or 24 milli equals I of 6 minus I sub x. One equation, two unknown. Two unknowns.
Should be 3.
Yeah, that's what I was thinking.
Negative 3. Yes, thank you. I sub x and 2 I sub x, 3 I sub x. 3. I need to rewrite them in terms of one unknown. Maybe I can use Ohm's law and write what the value is. Now remember, V is this voltage, plus to minus. So that means the voltage here is what? Plus to minus. That's what V is. So I sub 6, notice, is entering the plus. That's supposed to be. It's the voltage here, which is V minus 0, the top minus the bottom, divided by the 6K. I sub 6 equals what? V over 6, I'll go milliamps. Milli. Which is 10 to, maybe I'll change this to milli so the millis will cancel in a second. Now let me look at I sub x here. That's the current through this. Again, this is plus to minus. We define I sub x going up this way. So I sub x, since I define it going in, is going to be this voltage is going up. It's this voltage minus that. Well, what's this voltage? So 0 minus, what's that voltage? V divided by what? 2K. So I sub x equals what? Negative V over 2 milliamps. Now come back and plug them in. Plug this one here, plug that one here. So you will have 24 milliamp equals I sub 6, which is what? V over 6 milliamp minus 3 times I sub x, which is what? Negative V over 2 milliamp. The good news, since milliamp shows up in every one of them mathematically, you can cancel the milliamp out. That's like multiplying the equation by 1,000. If you multiply by 1,000, gone, gone, gone. So here's what we have. 24 equals V over 6. This will be plus 3V over 2. Now, I'm not a fan of fractions, so my first step is let's take this equation and multiply it by 6 to eliminate the fractions. 6 times 4 is 24. 4 carry 2. 6 times 2 is 12, and 2 was 14. Double check that. 24 times 6, 144, equals V plus 6 divided by 2, that's 3. 3 times 3, which is 9V. 144 equals 10V. And what's the voltage? 14.4V. So I know the voltage here is 14.4V. Can I find the power supplied by that source? Let me look at that source. Just focus on that source. You got a 24 milliamp current going up. You get a voltage labeled like this, plus to minus 14.4 volts. So is the power being supplied or absorbed? It's entering the negative, that's supplied. Current times voltage. 24 milli, 10 to the minus 3, times 14.4 negative 0.024 times the 14.4. 0.3456. So the power supplied by the independent source is 0.3456. Let's continue with the single loop here and single node quickly to show you where we use them. Let's say we have this circuit, that's single loop here, 9 volts. Plus to minus 3 volts. $100 minus to plus 5 volts plus to minus okay, I'll adjust that. 1 volt. I don't have room to squeeze, so I'll go like this. And that's 220 ohms. What can we do with these sources there? Can we combine them into a single source? Well, let's see. What do you see there? I see one loop. So I only see one loop. Let's do KVL. KVL said if I travel, if I add all the voltages in a closed loop, the result is 0. So if I start with this source, that's 3 volts, because it's minus to plus. Minus to plus, that's plus 9 volts. Remember, it's going to mark the resistor plus to minus. So that would be a minus, and the value of that voltage using Ohm's law, V equals I times R, 100I. Minus to plus, that's plus 5. Plus to minus, that's a minus 1. And this will mark it plus to minus, going this way. V equals I times R, 220 times I. Positive. Oh, that's a minus. I don't know why I put a plus there. That's a minus. And now I'm in trouble. No more white out. Come on. Always have supplies here. Nope. I know how to make it a minus. It's a fat minus. That's a minus. Yep. So we can combine these 3 plus 9, which is what? 12 and 5. 17 minus 1, which is what? 16 minus what? 100I minus 220I is equal to 0. And I can finish that, but I'm not interested in finishing it. Now watch this. Here's a different problem. Completely different problem. Let's see what the equation for that. We assume the current's going to go minus to plus, going to travel in that direction. So if we do that, we're going to have what? 16 entering the minus. It's going to mark this plus to minus and plus to minus. So this will be what? Minus 100I minus 220I equals to 0. Look at these two equations right here. Aren't they the same equation? So what this is telling us, if you have voltage sources in series like this, you can combine them into one voltage source. You just got to look at the polarity. Minus to plus, the same direction. I add them. 3 and 9 is what? I go 12, keep going, minus to plus in the same direction still. I'm adding the 5 to that answer. But this is plus to minus, I can actually subtract that value. And that's the reason behind it. If you do KVL and you travel around, you will see this plus this minus that. So when you see voltage sources like these, lots of them, combine them into one. And that's the same thing with current sources in parallel. So voltage sources in series, you can add them together. You can't put voltage sources in parallel unless they have the same voltage. So when you have current sources like this one, 5 amps, and let's say the voltage here is V. That's 10 ohms here. Another current source pointing down. That's 1 amp. Let's put 8 ohms. I'm just making things up here. And let's put a current source here. I don't know. What do you want? 9 amps. And I can put another one if I want down here. Who cares? We can keep adding them. Of 6 amps. I can have as many as I want to. All these connected in parallel. Notice this voltage is plus to minus. That tells me there's a current coming down. And using Ohm's law, I equals what? V divided by R. The current here is going to be what? V over 10. Because V equals I times R, which means I equals V over R. These two are in parallel. All of them are in parallel, but these two resistors in parallel. That means they have the same voltage. There's also a V here, and there's a current coming down here, and that's this voltage divided by that resistor, and that's V over what? 8. So if I do KCL, Kirchhoff current law, at the top, you take all the current going into that node should equal all the current leaving that node. And what is going? I see the 5 amps. I see the 9 amps going to it, right? What's leaving that node? I see the V over 10, that's this one. I see the 1 amp, I see the V over 8, and I see the 6. Five and 9, 14. Bring the 1 to this side, well, this is 7 here, so 14 equals V over 10 plus V over 8 plus 7. Bring the 7 here, you have 7 equals what? V over 10 plus V over 8. Now let's change that. If I gave you this circuit, well, if this is V, this current here, Ohm's law, I equals V over R, that's V over 10, and this current here is what? V over 8. If I do KCL here, seven going in, and what's leaving? V over 10 plus V over 8. Again, notice these two equations are the same. What that tells me, if I have current sources in parallel, I can combine them into one source. If they're pointing up, count how many pointing up. What do we have? What's 5 and 9? 14. What's down? 1 and 6, 7. 14 up and 7 down. What's the net result? 7 up there. Not the 7 up you drink, but 7 amps pushing up there. So when you see current source in parallel, you can combine them together into one source. When you see voltage source in series, you can combine them together into one source. And you're going to see us do that. You're going to see us also take these and maybe do combination on them, replace them with one resistor. These are connected in parallel. The previous one, they were connected in series. Maybe I can combine these guys into one. Because if you look at this, you can combine these two into what? Isn't that negative 320I? So that's having one resistor of the value of 320. Well, how do you get 320 out of these numbers? You add these two. Do the math here, that's different. The value of these, it will not be 10 plus 8. Will be actually 80 over 18, whatever that number is. But we'll show you how to do that next class.